Okay, very good. So first, Brian Anthony. I'm the Associate Director of MIT Nano. I'll be the panel chair for today. I'm a mechanical engineer, computer scientist. I'm going to ask the panelists to introduce themselves, but first let me just introduce the framing of the panel so they can use that in the context for their introductions. So the general area of the panel today, AI and ML to enable domestic production. Prior, we discussed a little bit how we can talk about some successes and struggles of AI and ML in manufacturing. We did hear a lot today about some of the important needs to incorporate the sector or the context focus in those endeavors. And then also, can we take that conversation of the successes and struggles and how important it is to have a sector focus to thinking about, well, what is the right alignment for a potential national initiative and what should the focus, how should that national initiative be structured, sector focused or cross-industry focused. So that'll be the theme, but let's just go across the way and just to introduce yourselves, and then we'll take a few questions, and we'll turn the questions over to the audience as well.
So I'm Larry Sweet. I'm the Director of Engineering at the ARM Institute. It's one of the 17 institutes. I think this is a great initiative, very, very successful. ARM right now, in terms of membership, is the largest of the institutes. We have over 400 members spanning the entire ecosystem of advanced robotic manufacturing. And I'll be talking later about some of my other experiences that are relevant. About a third of the 120 projects that we have conducted over our history, about a third of them have had some aspect of AI and machine learning. So there's a lot of success stories and also some learnings.
I'm John Hart, professor of mechanical engineering at MIT and also department head and co-director of manufacturing at MIT along with Suzanne Berger, and we're happy to be hosting our symposium and hope to see some of you there tomorrow in the same room.
Robert Rudnitsky. I already was introduced, but I work at NIST. My background is not in artificial intelligence, but beginning about 4 years ago, my division started working with the White House on a series of reports and workshops looking into applications of artificial intelligence for manufacturing. And then, of course, NIST has been very active in the area of artificial intelligence more broadly.
Hi, I'm Ken Hutchison. I'm an assistant professor at Penn State, ARL. I've been using AI in the defense sector on projects for about 12 years. And in 2021, received the Department of Defense Manufacturing Technology Achievement Award for that, for some AI and business process interactions on a project.
Very good, thank you. So let's kick it off. Let me just share a little bit of perspective. Over the last 5 years, we've been actively working with a packaging company, a fiber extrusion company, and a coffee roasting company to deploy deep reinforcement learning techniques for process control. And it was a hammer, and that had a bunch of nails that we were able to find across industries. That was very successful from my perspective, and sort of really changing the way that we improve yield for all these different types of manufacturing, continuous manufacturing processes. So my question, what I'd like to sort of kick off with is if you can give some highlights of if you can name companies, do so, or sort of areas that have been very successful in your experience of either sort of nascent implementations of AI and ML in manufacturing, or if you want to contrast with some of the negative things that have worked. So pros and cons, things that have worked, things that haven't worked.
Well, I'll give two quick examples. One that is actually one of the projects at ARM, the ARM Institute, and one that had a different start. Both of them, actually what's interesting is based on the presentations we've had today, these are really good examples that validate what we've heard already. So both the two that I'm going to cite is Titan Robotics, which is a spinoff of Carnegie Mellon located in Pittsburgh, Pennsylvania. What they've developed is machine learning-based robotics that can do machine learning to identify defects on the surface of, let's say, a F-15 fighter wing. And the objective of the business objective or the value proposition is to be able to get the airplane back up in the air as quickly as possible. It's really not so much about labor saving or cost. It's the value of getting the airplane back in service is very, very high. On the surface of an F-18 wing, there may be 4,000 fasteners. That airplane's going to be 40 or 50 years old, so it's been reworked many, many times. So a priori, you have no knowledge of what those fasteners are. So a large FANUC robot mounted on an AMR surveys the surface, and identifies all the fasteners, what's their condition, what types they are, with about 95% reliability, and then comes back and replaces those automatically. So that's what they do. The other company I'll talk about is Symbotic. It's a local startup here. I was involved initially helping launch that company from day one, later became the CTO. That company is in the warehouse automation space. They are now a $1 billion a year revenue company. What they share is that they had intense involvement from the end users on the project team, fully integrated as one team from the very beginning. So it was not a typical situation that we often find where you have a startup that's not connected to an end user, and they go out looking for customers and how do I get across the valley of death. So it was much more engaged all the way through, and I think the examples we heard today fit that. I think the thing that was different about Symbotic is that initially they tried to replicate human behavior. The task in a conventional warehouse is picking orders to build aisle-specific pallets for stores and deliver those. They started off by looking at what the people who were the best at building those pallets were able to do. And the other task was to be able to bring the cases to the palletizing robot in perfect sequence. And again, they tried to use heuristics to do that. Both of them failed, and it took us a couple of years to work our way through it. What turned the corner was to be able to actually integrate with engineering processes and mathematics. And the things that actually were the key success factors is that iterate together the advanced mathematics, programming and planning algorithms from control theory, integrating that together. So the system that Symbotic is selling is now being deployed across the Walmart network. And so that's what's driving their revenue growth. If you go to their website now, you're going to see a lot of AI plastered over their website in different places. I have 35 patents on that system. None of them were based on AI. They're now coming back and using AI to take it to the next level.
Share any other examples?
Sure.
You go ahead.
Sure. Yeah, so I guess I used two projects that are kind of different and why I thought they went really well in terms of the AI component. The first one was with DARPA, and it's called a Refence. And the idea is to use generative design to create alien corals, if you will, that provide a place for, biological habitats and to preserve shorelines and so on. They tested that in Miami. I think that was successful because the problem itself was extremely understood. Like, you can model everything around that, so the AI has a good feedback loop. Anytime that we end up touching like contractor data, things get a lot messier. So the second one would be, I've worked with a Navy shipbuilding contractor to kind of streamline some business processes there. And the two main reasons why that went well, the first one was because they had really good data hygiene and curation practices, which was really, really good. And then the second reason it went well is because we had really good stakeholders there. Like, it wasn't that we showed up 2 years later with a model out of a vacuum and said, hey, please replace your day-to-day with this. They were interacting with us throughout the entire process, and there were a few aha moments where they would say, oh, this is stuff I used to have to do by hand, and now I'm kind of freed up to do more productive things with my time that I enjoy. And when things like that happen, that was really a good prognosis, kind of exciting.
I can go ahead. So maybe to speak in general terms, the success stories I've seen involve some combination of identifying the accessible needs, so the places where an AI tool can help, having individuals who can survey the landscape of commercial capabilities available and then judge which ones fit the needs, and then defining the measures of success, maybe to state the obvious. Where's the operational impact? Where's the business impact? And how does that allow you to advocate the outcomes with management, with leadership? And to echo the first point, and building a team that has the AI and data science expertise and can spend time on the manufacturing floor. And be able to stitch things across levels. I've seen particular examples of this succeeding industry, processes and workflows that are centuries old, companies with knowledge that's layered, generation upon generation, but a huge opportunity to, better understand everything from predictive maintenance to how to accelerate qualification for customers to just identifying hidden variables and workflows that would, otherwise not be identified. And it's not, kind of breakthrough AI technologies. It's just sort of basic, neural networks or Bayesian approaches to predict next outcomes, and then turning that over into a roadmap over time.
Yeah, I'm not sure if my mic is
You're on, yeah.
I'm on, okay. Yeah, I'll just kind of build on what everyone else said. For us, when we're trying to look at this from the point of view of planning out programs, we look at where are the challenges. And the challenges that we keep running into mirror what we heard throughout this morning, right? The topic of we need to have good data, we need to have lots of data. And where we saw successes is where companies were able to get that data. Where we're trying to go and where we're starting to see some successes is, and I think your institute has seen a fair amount of this, is where we're able to get companies and universities to work together to share data. Because if you think about the examples we heard this morning, everyone came back to, I need to get large amounts of data, and they talk about it at the enterprise level. But what we look for is, can we get enterprises to work together to increase the available data? And for that, you need to have some kind of standardization as the path forward. You need respect for privacy, some amounts of anonymity, and protection of IP. And we've started to see that in some trial efforts. We've seen that in some of our institutes. We have an effort going on right now, funded by NIST, combined with NSF, but working with Seagate, and there'll be some reporting out on that coming up. So it's where you can get those elements in place to get the large data sets together, and then you can see a lot of progress.
My next question is going to be at the intersection of simplicity and sector. We heard, I think, from Prakash a little bit domain-led, digitally enabled, and then we heard from Wojciech, who said, hey, no, we're going to put the Gen AI and the large language model in the room with the domain expert and computer scientist, and we're going to have something that works across industries. So it's been my experience that the big shiny stone on the hill, the companies, hey, ML, AI applied, we're going to solve all the world's problems. We spent a year one time working with a company where we're working with the data scientists to say, hey, our data is sampled at 100 hertz. And it took us a year to finally get to the engineers that said, well, no, actually, it's on average 100 hertz. Sometimes the sampling is 99, sometimes it's 101. And so just that fundamental basic thing. It's like the basics of signal processing, the basics of data acquisition. So I'm struck with, yes, we can definitely take more advantage of better data and higher quality data. But I think what I'm seeing is a lot of the low-hanging fruit, or there's the needs for both small companies and large companies, just to get the basics of instrumentation, the basics of where do you get this data to pipe into it. So that's sort of the one point. And I think the second question is, well, are some sectors, semiconductors is being treated differently from the institute perspective. We have biopharma, we have sort of box build, chemical. So is there a particular sector where we should look to as the exemplar? Or how do we, is it in every sector, is it just, we're going to avoid these stupid problems and the big mistakes by just going back and making sure that we use ML and AI as the driver to get the basics in place? So what are the basics that you're seeing? Are we satisfying the basics? Where's the sector that we should be focusing? And where do you see sort of that sort of playing out?
Well, I'll answer by just not answering.
Yeah.
In my talk, I made the point that for our upcoming institute, that we're leaving it to proposers to suggest what sector or cluster of sectors need to be worked on, or whether they should work cross-sector. So given that we have a funding opportunity coming out very soon, I explicitly will not be answering that question.
Fair enough.
Yeah.
Well, let me turn it over to others. But so I think, is there, my personal bias, I do a lot in electromechanical production and sort of have seen a lot in terms of just the opportunity for amping up the way that we do real-time feedback control and the way that we do statistical process control in packaging, in sort of continuous extrusion. And we have, at the same time, benefit from tools like from Siemens and Rockwell that have existing controllers. So I'm struggling a little bit, like, hey, we can do a deep sector focus and know everything there is to know about semi, or everything there is to know about pharma. But then how do we go deploy? And do we need to replicate the infrastructure that a Siemens and a Rockwell have in terms of both hardware and software platforms that are easy to deploy? And where does that, we won't put you on the spot. But yeah, sort of looking at what, is there can we put in the Institute a sector that is, hey, this is the shining example where this is how it should be done, and one that is, hey, you need to do the basics first and connect those two?
So, well, I'll use this Symbotic example. The parent company that was investing in this startup was the largest wholesale grocer in the country. And so we had, we built our first warehouse. We were shipping to 160 Stop and Shops in the Northeast. So we had all the data we could want, and that was representative of any retail supply chain that's building mixed pallets that you're going to send. They're built, basically it's an NP-hard problem to solve. And so it was something that really had broad expertise. And if you look at the warehouse automation industry, a very large sector of that is devoted that way. So we had the data. We built very, very detailed simulation models that literally simulated everything down to the hour. And so the presentation that was talking about using generative AI to be able to go around that circle, we didn't have that. But the steps that they were using were there. And so because we had a validated real-world digital twin, if you will, we could always test out every iteration that we were doing as a team. We went through probably 25 iterations of the warehouse. We'd come up with an idea. We would test it. We were iterating on the algorithms, the scheduling, the design, combination of industrial robots and mobile robots running together. But very, very quickly, we could come up with a new iteration, and that's what led us to the final success.
I don't know if there's a sector that will stand out above others. In my opinion, I feel like it's ultimately a combination of maybe some priority sectors or one that's chosen to be a good focus area, and types of models, right, and types of processes, right, continuous processes, discrete processes, and understanding the rows and the columns, so to say. I'm personally excited about accelerating the translation of new processes to scale, or bringing new materials on board into existing process flows, let alone new process configurations. And I feel the combination of all the tools we discuss has a big role to play there, and we're seeing sort of more examples demonstrate traction. Or in the case of Symbotic, I'm sure a big part of defining their success and allowing the hardware to exhibit such complexity in its operation and its performance. Need to teach our students more of that too.
We'll go back to the students in a second. That's the next probing question.
Sure. I guess in some of the areas I encounter, security can be kind of a bit of a drawback. And while there are a lot of things people would like to try and they're aware of, because there's a gargantuan amount of things out there that come out weekly even, there are not a whole lot of solutions, I don't think, for like on-premise development so much. Typically, the majority of the pathways involve passing your data through external companies, which in the spirit of sharing, we should want to do that, but at the same time, we shouldn't necessarily all be sharing with an independent party simultaneously.
One of the themes that certainly came up, I think, we had the digital versus engineering convergence, and in the class that I teach, I say, well, you need to have simultaneously a physical context and your data context. How do you do that on a team, or how do you do that on an individual? It seems, on the one hand, I've advocated for having data broadly, computation, as a language that does permeate all of engineering. At the same time, we need people that focus on the language. So I'm just wondering if you could comment on your personal experiences sort of leading, working in teams, in terms of how the teams are structured with, is that the engineer is at least understanding the vocabulary of the data science and what is the possible, even though not knowing how to deploy, but at least the questions to ask. And then the IT, data science folks say, hey, well, here are the tools, no idea what the right questions are. How do you embody that in an organization, in an individual? It seems to be one of the strong roles where we should be looking at in training and education and workforce development in our established institutes online or for sort of a new institute. But just reflecting on embodying it in yourself or in a team, what does that look like?
Well, the spirit of the institutes, this is what, Robert, what you mentioned, is that we intentionally create collaborative teams. And so the collaboration is cross-disciplinary, but it's also in terms of different types of, so we'll have universities, startups, the end user, let's say the major robot companies, sensor companies, et cetera, all working together. And overwhelmingly, the feedback we get from those teams is they feel this is a unique mechanism that previously was not available to them. So if you think about, I'll give you an example. If you have, we're doing a project where we're doing ultrasonic welding of thermoplastic composites. This is something very rapidly emerging trend in the aerospace industry. What that requires is you're inventing a new manufacturing process on a new material all at the same time, and then bringing in all these different technologies together. So we've invented new sensors, new ultrasonic welders, the material technology, and the AI on the algorithm in the control. So on that team, we've got universities, startups, et cetera, that composition. So bringing that together, I think, is very, very, very powerful mechanism. And now the different institutes, I think, are set up in a different way. We've put a big emphasis on having a large ecosystem. And so a lot of we do work, we have a laboratory in Pittsburgh, we're near Carnegie Mellon. So we have the internal team, and I lead that technical team. But a lot of the intent is to get a lot of the funding out into the members. And so they're actively participating. My understanding is some of the other institutes are more, the funding is going into the institute, and so it'll be interesting how the institute you're proposing will be structured.
Yeah.
So, please go ahead. Yeah. So I just want to let the audience know we're going to come to you for questions, so we having them in the back of your mind. I have a hair to comment here, though.
So first I'll build on what Larry just said. We do have a range of different structures in the institutes. Some of them are more place and facility based, and some of them do their work distributed out at companies and at universities. And for the AI Institute, we're not specifying that, at least not in the notice of intent. And I think the challenge that you laid out, Brian, initially is one that we've seen in a lot of cross-disciplinary fields where two different disciplines need to get together, right? And so you spoke about the engineers learning the language of programming, or at least being comfortable with the concepts of it. We've seen this in a lot of different cross-disciplinary fields. I remember at one point I'm a physicist. I was doing a collaboration with biologists. They started talking about Daltons. I was talking in nanometers. I was trying to figure out just how tall Dr. Dalton was to figure out what 112,000 of those might be. You have to build that out. I think where you can get progress here in an institute structure is developing that common language. And institutes, regardless of whether they're place-based or more distributed in their work, are very good at bringing together teams of people from different disciplines to work together and develop that language. In this case, this institute is being sponsored by NIST. And NIST is now, I'll get this, roughly 120 years old. I don't remember whether it's 122 or 123, but call it 120 years old, order of magnitude. So NIST is about standards and ways of measuring things. Standards are about developing a common language and a common way of doing things on a voluntary basis. And I think you can anticipate that a NIST-sponsored institute will focus, in part at least, on developing those kinds of standards for working together and getting companies to work together. Ken, you talked a bit about these issues of trust. And trust is something that's developed over time. And again, this institute structure has been very good at that. I know in Nimble, which we fund, we have the largest biopharmaceutical companies working together in a way that really they have not done previously. So the hope is that something similar happens here.
I can just share quickly an example from a different domain. We run workshops with companies interested in exploring and adopting additive manufacturing technologies, aka 3D printing. And after lots of lecture-based courses and online materials, we found a very effective approach to bring people from across the organization together, have some background knowledge, and identify potential use cases. And discuss, in this case, if you're familiar with 3D printing, it's like, okay, what's the geometry, what's the material? We have a cost model, and then the back and forth of what makes the technical fit and the economic fit, maybe not unlike one of Ben's charts before this session. And just crossed my mind, maybe there's a similar manifestation for organizations to get together and think about, okay, how could we deploy AI and ML for manufacturing and operations?
Sure. I mean, typically on a team like this, I'm usually a technical person, so probably the less pleasant one to work with. But, I do think it's very important that when you're trying to implement something like this, there's a long-term strategy in place. And it's not just consultants disappearing or, your workforce needs to have access to people, both teammates and resources to keep that going. Because, the technical people are grading. You don't want them around all the time.
So I just wanted to give the opportunity for you to ask some questions. So please, you can either raise your hand or go to the mic. I don't want to put anybody in the spot because we're not going to have the exam at the end of today. Please, go ahead.
My name's Chris Hill. So I recently finished a AI project with MXD focused on obsolescence and electronic design, trying to predict obsolescence and then providing feedback to designers. The concept was probably put together back in 2016. We started the project probably just a couple years ago and then finished up at the end of 2023. The vision was to really provide a model that all of industry could use, right? And then when we started working with the OEM, we started working with the supplier, the focus quickly changed to what they needed, right? And so then we, which was manufacturing. That was somewhat successful. I will say, I think institute-type programs, I've been involved with a lot of them. There seems to be the what you do for the project for those companies, and then there's the what gets kind of proliferated to the community and through the institutes, and sometimes there's a disconnect, I think, between those two. So I guess my question is when we have a project like that, and our vision is to really provide, the end user, the sustainment, the maintenance, and everything else that's going on with obsolescence, not just to manufacture a part. How do we take those models? How do we take those projects and then put a framework in place to say, how do you go to the next step, right? Because I've been involved, again, with a lot of these projects, and we do great stuff. We do great stuff for that company, and yeah, we could maybe productize some stuff there, but the reality is that it's not a straightforward, how do you build that out to other companies, and how do you address it? So what are you doing there to address that area?
Well, I'll share the experience we're seeing right now in ARM. We have had a high level of success in the projects being successful, getting to a laboratory demonstration phase. And in the TRL, MRL nomenclature, that's basically a TRL 4 or 5. But we want to, looking forward, the example of Titan Robotics, and we have several others, were more successful, and they're actually going into production. So we're saying, well, okay, what are the things that we could do differently? And in fact, the mechanism that we use in these institutes is what we call a project call. It's basically the request for proposals. And we're being much more specific about what we're looking for in the project call. Literally, the concept papers are due tomorrow. I've been in my role for about a year at ARM, and I was concerned that there were very, very few robotic system integrators that were part on these teams. So if you think about the robot industry, and this certainly would apply to semiconductor, is in between where the technology is being developed and the individual components being developed and the end user. The system integrators play a critical role. They're in between. And I went out to Fanuc and Yaskawa, the two largest robot companies in the country. They have access to their integrator networks. Between the two of them are the majority. And I went out and talked to the Fanuc leadership there, and they took me out to their integrators. And what we found is the integrators were very reluctant to pick up the ARM technology. And we went through and did an analysis of why that was the case. And I'm actually going to be presenting on this topic tomorrow at the Robot Summit here, and then again next week at Automate, which is the largest robot show in the country. And I'll be sitting at the Automate show. On the panel with me are the leaders from Yaskawa and Fanuc, from Southwest Research, where they developed the Ross Industrial software, and new companies that are emerging that help bridge that gap. And we're intentionally asking in this year's proposals for the proposal teams to be much more specific about their technology transition plans, how they're going to do it, and what we expect. So I think there's something that we've discovered in the way things were done in the first few years that built up a backlog of really, really good technology. But now the question is, how do we open the gates to make it really transition?
Scale it.
And this is something that hopefully this is really going to be an opening for other institutes as well.
Yeah, what's the productization of the components that allow you to scale and share your best practices across?
Yeah, and actually, if you're interested in the details, either of those venues will be able to, you'll get a lot more detail on how we're doing it.
So I think you mentioned the need to share data across different organizations to be able to scale some of the technologies. I just want to mention and ask, what do you think about the role of academia as an arbitrator of data? I think at least at MIT we have a few examples where industry partners are actually sharing quite sensitive data. This is in a place like the Center of Biomedical Innovation that I know personally about sharing data on internal contamination in plants, which is maybe the most sensitive data you can imagine. And the idea is that it's being shared confidentially with MIT, and then it's being aggregated in a way that doesn't reveal private information, confidential information. So I wonder if that thought has been considered, because I think that potentially academia can play that role.
Yeah. I would actually just add one other piece just on the academic side. I think the data privacy is an important issue. The data pricing, how do you get, if you're going to share your data, is there, between companies, is there an economic incentive? But then also, just to have something in the back of your mind, there's a rapidly evolving set of encryption technologies called homomorphic encryption that allows you to do end-to-end analytics on your encrypted data. So I never have to decrypt my data to do analytics. Like I say, I can take my number 3, encrypt it, take my number 2, encrypt it, give it to John, because John's an expert in mathematics, and he knows how to do addition. He adds the encrypted 2 and 3. He doesn't know that he has a 5. He gives it back to me, and then I decrypt it, and I know I have a 5. So never, except for the data owner and the output owner, did I actually see the white space, the clear text. So as another way to enable sharing, I think that's an important piece that's coming in. Companies like Samsung and Microsoft are developing both hardware and software to enable that. But to Retzov's question, sort of the data sharing, is there a role for either academia or an institute, sort of aggregating data, sort of incentivizing companies to share data? How do we play that game?
Well, at ARM, we've actually been awarded a 3-year contract called AI Data Foundry, and it specifically has that mission.
the mission of aggregating data?
It's basically working with building a data foundry is to try to address the issue of having data that could be available to the manufacturing ecosystem. And it's particularly focused on how do you, companies, let's say like a Boeing, they have a lot of data that they're collecting internally. They actually have been forthcoming and being willing to share pieces of it with us to help us build up this capability. But we also spend a lot of our effort on workforce development and supporting small and medium-sized businesses. They don't have the resources to do it. And so if we have have databases that are relevant, then it may be more accessible to them.
Yeah, please, go ahead.
Sure. Yeah. So I think academia is a very useful vehicle for this, but there probably needs to be consideration, right? Because you can tease information out of models that are pre-trained in a transfer learning context. And so it's still an open question as to whether or not you can bound how much somebody can get out of a model you're transmitting. And given that we're training models basically on the entirety of human knowledge right now and then pivoting them to do time series forecasting, zero shot, stuff like that, the scope and complexity of those models that you're transferring, I would think has to be limited, or at the very least complicated routines performed to try to extract PII or whatever that may be out of it.
I'll just answer briefly. Yeah, so outside of an institute model, obviously academia has had a role as an arbiter of data transfer and sharing. Inside of an institute context, I would say there's been two types of roles. One is universities have played a role at the project level, where they've also been an arbiter of data to move a project forward, but also universities have been consortia leads, or spin-offs of universities have been consortia leads to launch universities. So it's kind of at two levels where universities can play a role. In either case, the key to it is, I'm going to say it in the soft way, developing trust among the partners, and in a broader way, developing the structures for trust among the partners. But yeah, absolutely, university can play a role in a variety of ways.
I would just add, I mean, in my experience has been also I've had worked with companies that have been very willing to share their data and have it accessible for research. But speaking to some of the other things we heard earlier about the data engineering, the cost of data engineering, context is king or queen. It's both. It's the royalty. You know, for example, you can have great, if you want to do predictive maintenance, right? So you would like to take your IoT data, your process control data, that is generally very well logged and it's on the factory floor, it's probably streaming to a database someplace, great. And then I want to develop some models that can use that data to predict the health of the machine. Well, how do I do that? I probably should know something about when maintenance has been happening in that machine. And so aligning that data, that process data with your maintenance logs, give me a year, and then maybe the team will have it for me. So yes, we may be able to share our data, but is it going to have all the context? And whether that be, you know, there's a struggle with getting that context visible within an organization, let alone what happens when you share the data and somebody's now trying to make use of that data and has nobody to go talk to you about where that context was. So I think that's one of the big challenges, to fully contextualize all the data to be able to, that are coming from people that may want to share it. So I think that's a pervasive problem within an organization or academia or an institute serving as a convener, having that fully articulated, fully descriptive metadata to give the full context, because you're not going to be able to talk to the expert or the engineer that understands the process for that data came from. Okay, so we'll take one more question, and then I have a closing question for the panel.
This question is for Robert. So I have done a lot of cloud migrations, and whenever we do cloud migrations, we just lift and shift, or the data is almost the same that goes up onto the cloud. So do you think your organization can have a mechanism to standardize data once it moves to the cloud, to set some governance for standardization, which could be reused, distributed without any legal consequences? You could take the PII out of it, and, you know, is that an opportunity or not?
It sounds like an opportunity. I mean, at the level that I was referring to it would have been at an earlier stage, before it goes to the cloud, to develop the standards for how the data comes out of equipment and standardization across the equipment and within a facility. You're raising an interesting point about whether it could happen at a later point, and I think maybe. I think there's a room full of experts here who probably could weigh in on that one.
So we're getting close, been sort of being tasked with getting back on a little bit of schedule. So my closing question is going to be each one of you to, what is the one thing that you would like, that you're really passionate about, that very targeted, that you would like people in the audience to reach out to you about? If they have an interest in this thing, let you know. So we'll start with Ken. I'll continue to talk for a little bit, I'll start at the end. But what's that one thing that you want to let the audience know that, hey, if you want to talk about this, come look me up?
That's a tough one. I'll go with generative design. I'll take generative design. I think that's pretty much it.
This isn't going to come as a surprise to anyone, but I would say if you're passionate about trying to use machine language, artificial intelligence for improving the competitiveness of U.S. manufacturing, that's where my passion lies with this upcoming institute. And what I'd like you to do is, you could reach out to me, but more so, go out and form a team, go out and join a team, make this institute wildly successful, find ways for your companies and your universities to participate in it. This is a game-changing moment, and I think we should seize it.
How MIT and mechanical engineering in particular can train its students to be more as useful in your organizations?
So my things that haven't been done before and have them have a high impact on a large scale. And so I think the presentation earlier today, talking about understanding the value and what are the things that would transform a factory. I've had experiences where we've improved the whole factory by 30 to 50%. So identify what are the 2 or 3 things that are really going to make that difference, not put a big investment into something and then you find out, yes, it was technically successful, but it really didn't move the needle.
And my 2 things would be sort of the application of deep reinforcement learning or machine learning in real-time process control. So at the edge, sort of moving way beyond what you could potentially do with classical controllers, PID, what have you. And also in the space of our workforce. How do we sort of make sure that we can be conversant, the data scientists with the engineers and engineers with data scientists, but doing that within organizations, understanding the context and the examples within organizations. So that's an area that I do a lot of sort of professional training in, and so love to hear your challenges and opportunities. So with that, I want to thank the panelists. And thank you, and I think we're doing a break now, but I don't know what the detailed schedule is, so I'll hand it back over to Emily.
All right, that was a great discussion. Thank you again to our panelists and moderator. I'm sorry we had to, again, cut the questions a little bit short, but I'm hoping that the conversations can continue over lunch, which is up next. We will break for just about the next 45 minutes. Food and beverages are set up in the hallway outside, and we do have vegetarian and gluten-free options available. Again, we'll reconvene here at 1:30 p.m. for remarks from Georgia Parakis, the interim dean of the MIT Sloan School, on how Sloan is responding to and leading in AI technological advances. Thank you, everyone.